I'm Anil Kumar, back with you with a revised version of my video on rationalization. So for that, let me thank my friend Pradeep, also my batchmate, who pointed out a critical mistake. Now that gives me an opportunity to explain this topic even better. So I hope you like it more than you liked it before. So thanks Pradeep for giving me this opportunity. So let's begin by saying the same old thing, that is all what you need to know to start calculus. Factoring, rationalization, equation of tangent line, advanced functions, rate of change of different functions. And while working with problems, you need to express situations as an equation, basically relating two or more variables, and many times working with combination and composition of functions. So in this particular video, we are going to talk about rationalization, correct? So the idea here is to work with radicals like, let me give you an example. If I have an expression like square root of a plus square root of b, it is really very difficult to work with these normally. So what we do here is we apply the technique of rationalization to make them simpler to understand. Now square root of a plus square root of b means that a and b, let me write b and a, both are greater than 0, right? Since within the radical sign, when we are working in the domain of real numbers, we don't have any real number for square root of negative numbers. Now, another term which I am going to introduce here is conjugate of this. So conjugate of square root of a plus b will be square root of a minus square root of b. When you multiply these two terms, that is to say, when you do square root of a plus square root of b times square root of a minus square root of b, which is its conjugate, what happens? Let's do it. So when you multiply these two, you get square root of a square minus square root of ab, and when you multiply by b, you get square root of, you could write ab or ba minus square root of b square. Now what is square root of a square? Big question. What is square root of a square? Well, I'll provide you with the link which says that square root of a square is indeed equals to absolute value of a, not just a. Now in our case, since a is greater than 0, absolute value of a is equals to a, and that is why I'm going to write this as square root of a square as a, correct? Now here these two cancel out and square root of b square will be b, since b is also greater than 0. Perfect. So what you've seen here is that the radical expression square root a plus square root b, when multiplied by its conjugate, results into difference of a and b. Much simpler term to understand. You get the idea. So this is the basic concept, right? And this concept will help us to factorize. It will help us to write equation of a tangent line. It is a very important technique to be used in advanced functions and essential to do rate of change, especially when radicals are involved. Now we have got these examples where I've changed two of them. This is very important example, made a minor change here also. So this is really a revised version. So those of you who have seen the previous version, I'll recommend them to see this particular version also. Our emphasis here will be how each of these expressions will be applied in calculus. To give you an idea, if I write x equals to 0, then what do we get? We get square root 1 minus 1, which is 0. 0 over 0 is not defined, correct? So if I substitute x equals to 0, this expression equals to 0 over 0, which is not defined. Correct? Here also, if I substitute h equals to 0, I get 0 over 0, which is not defined. So for all such expressions which are not really defined for a value, well, we don't know what really happens when we approach 0. By rationalizing these expressions, we will know exactly where are we approaching. That's the whole idea, right? That's the whole idea. And when we have expressions like these, then we'll be talking about x approaching a large value, infinitely large value. So at times we rationalize numerators, as we'll do for all these examples. And here is a very typical one where we are going to rationalize both numerator and denominator. Correct? So let's take them one by one and see their importance. I hope this video will help you much more than the previous one. So we'll take up the very first example, which is rationalize square root of x plus 1 minus 1 over x. Now let's first talk about its importance. How is it important? Why do we do so? This is very important for us to understand. Imagine if x is very close to 0. What happens? As you can see, if I substitute, let me write down. If I sub x equals to 0, what happens? Square root of 0 plus 1 minus 1 over 0, and that gives me 1 minus 1 over 0, correct? So we are substituting x equals to 1 in our equation, and that gives me 0 over 0. And clearly this is something which is undefined. Right? So we do have a restriction here that x is not equal to 0. That's okay. The question here is, what happens when x is very close to 0? You understand? What happens when x is approaching 0? We are not aware of. Now rationalization helps us to answer this question. Let's see how. So now I'll copy this and rationalize. So we have square root of x plus 1 minus 1 over x. Now we are rationalizing numerators. So let me write down here what are we doing. We'll rationalize numerator. That means I have to multiply and divide by its conjugate. Conjugate means I have to change the sign. So that is square root of x plus 1 divided by square root of x plus 1 plus 1, right? So that is the conjugate. Do you see that? So this term is the conjugate of this term. Do you see that? So when you multiply the conjugates, you get a square minus b square. That is to say, you get x plus 1 square of this minus 1 square is 1. And in the denominator, you get x times all this. Let me write that in bracket. Plus 1. Now, the numerator x plus 1 minus 1 gives you what? It gives you just x, right? So it gives you x over, we have x within brackets, square root of x plus 1, correct? Now, we can cancel x, correct? Of course, we should remember that x cannot be equal to 0. Only then this is equivalent, right? At this stage, I could write this expression as square root of x plus 1 plus 1. Well, we cannot equate x to 0, but what happens when x approaches 0? When x is very, very close, we say very, very close to 0. Then what happens? Let's substitute and check, right? So what really happens is it becomes 1 over 0 plus 1 plus 1, which is half. So we get answer to our question. The answer to our question is that when x approaches 0, then this function, let's say y equals 2, then y approaches a value which is half. Do you see that? Y approaches a value which is half. So we get insight to our function by rationalization. This is, I hope, a very important aspect of rationalization, and it is to be appreciated as we move on to calculus. Now, let us rationalize the expression square root of 2 plus h minus square root of 2 minus h divided by h. So what should be the first step? We have to multiply and divide by its conjugate, right? That is the first step. So this is the given expression. Let's multiply and divide by its conjugate, which is square root of 2 plus h plus square root of 2 minus h divided by the same thing, right? So that is as good as multiplying by 1. So we are necessarily not changing the expression at all, correct? Now the numerator will be rationalized. So we get difference of squares. So we get 2 plus h minus 2 minus h, and in the denominator h gets multiplied by all this, which is square root of 2 plus h plus square root of 2 minus h. Now the numerator, 2 minus 2 is 0, h minus minus h is 2h, divided by h times square root of 2 plus h plus square root of 2 minus h, right? Now you can cancel h and h and write this given expression as equal to 2 over square root of 2 plus h plus square root of 2 minus h. Now my question to you is, we had this expression and now we are saying that is a simplified expression. How does that help? So you have to list me the advantage of doing all this. Well, as we talked about it earlier, if I substitute h equals to 0, then what we get here is 0 over 0, which is not defined. Now if I do the same thing here, what do I get? I get 2 over square root of 2, right, plus square root of 2, which is 2 over 2 times square root of 2, which is 1 over square root of 2. So that really shows that as this expression, whatever this expression is, in this expression, as h approaches 0, that is kind of approaches, so we say as h approaches 0, the expression value approaches 1 over square root 2. Do you see that? So we have an idea, clear idea of what we are leading to as h approaches 0. So that is a very important aspect which we'll be appreciating a lot as we get into calculus. Now let me take another example here where we just have one term. It's not even in that form of numerator and denominator. Now here also we have an advantage of rationalizing. Now if you look at this expression, if x is a very large value, let us say if x is approaching infinity, so now you're familiar with this arrow, we mean approaching large value, let's say very large value. Then what happens to this expression? What happens to this expression? Right? So it is not very certain, since something within the square root, it seems to be approaching x. You could approach 0. you really are not very sure of. Now once we rationalize, we'll be very clear about it, right? So let's rationalize this expression. So what we have here is square root of x squared plus x minus x. To rationalize, we'll multiply and divide by square root of x plus x divided by, let me do here, square root of x squared plus x plus x. The numerator becomes difference of squares, which is x squared plus x minus square of x, which is minus x squared, divided by all this. Square root of x squared plus x plus x. Now x squared cancels, so you get x over square root of x squared plus x plus x. So that is the expression which you get. Now tell me, what happens when x approaches infinity? That is a very large value. Now let me show you some math here which is very useful from advanced functions also. So this expression, let's look into this expression, can be written as x over square root of, I can factor out x squared. So if I factor out x squared, I get 1 plus 1 over x within square root plus x. Now, what is square root of x squared? It is absolute value of x, correct? So we get this over absolute value of x and within square root 1 plus 1 over x plus x. Now if x is very large, if x is very, very large, then 1 over x is kind of 0, right? Approaching 0. So that term approaches 0. So I could write this particular expression as equal to x over absolute value of x plus x. Correct? Now, from here, if x is approaching positive infinity, then absolute x is x. So I could write this as x over x plus x, which is x over 2x, or this is equal to half. Do you see that? So if x is approaching a very large positive value, this particular expression approaches half. So this concept will be very much utilized when we talk about limits in case of calculus. So now you see direct correlation. I hope that helps you to understand and appreciate why we are doing rationalization and practicing such examples. Thank you. Now here is another interesting example. At times we may not have anything in the denominator, and even then the question could be rationalize this. That means we need to rationalize numerator. Right, there's only one term here. So what we are going to do here is we have x squared plus 3x plus 4 minus x. To rationalize, we'll multiply and divide by its conjugate. So it is x squared plus 3x plus 4 plus x divided by square root of x squared plus 3x plus 4 plus x, correct? Now, numerator is a squared minus b squared, so we get x squared plus 3x plus 4 minus x squared. And the denominator will be all this, which is x squared plus 3x plus 4 plus x, right? Now here you can see that x squared minus x squared is 0, so you're left with 3x plus 4 over all this. X squared plus 3x plus 4 plus x. Now the question for you is, how did this help you? Right? So think about it. We did rationalize, we did so much of work with the simple looking radical function, and we got something. Now how does that help you? So think about it and let me know. Okay. So here is the last one, which is kind of interesting. You find that we have radical sign in both numerator and denominator. So in such questions, we will rationalize both. both numerator and denominator. Do you get my point? So that is to say, so if I begin with this expression, which is square root of 6 minus x minus 2 over square root of 3 minus x minus 1, I'll multiply first by the conjugate of numerator, which is square root of 6 minus x plus 2, divided by square root of 6 minus x plus 2, and then by conjugate of the denominator, which is square root of 3 minus x minus 1, it becomes plus 1, square root of 3 minus x plus 1. Is that clear? So that is the conjugate of denominator, this is the conjugate of the numerator. Perfect. So when you multiply, these two terms will give us 6 minus x minus 2 square, which is 4. And let me write this in a bracket, okay. And this term, which is square root of 3 minus x plus 1. As far as the denominator is concerned, we can multiply these two, rationalizing the denominator. So we get 3 minus x minus 1, correct, as this term. And we are left with that, which is square root of 6 minus x plus 2. Now, 6 minus 4, let me write here. 6 minus 4 is 2, so we get 2 minus x here, divided by 3 minus 1 is 2, we get 2 minus x here, correct? And what we get here is 3 minus x plus 1 over the conjugates, right, of both numerator and denominator. Now, as you can see, we can cancel these factors. And it simplifies to 3 minus x plus 1 over square root of 6 minus x plus 2. And of course, we did cancel it off, but we have to write that x should not be equal to 2, right? Should not be equal to 2. However, you will understand that as x approaches 2 from either side, left to right, what happens to this expression? Let's say this expression is y or f of x. Then y approaches what value? So if you substitute 2 here, then what do you get? So if I substitute 2 here for x, 3 minus 2 is 1, right? So what I get here, as soon as I substitute 2 here, I get, let me show it here, square root of 3 minus 2 plus 1 divided by square root of 6 minus 2 plus 2, right? So 3 minus 1 is 1, 1 plus 1 is 2. And so this is 2. And denominator is 4 square root, which is 2. And 2 plus 2 is 4. So we get half. So y approaches half. Do you see that? So we could not figure this out from the given expression. You're getting the idea. Perfect. So that is how we could actually work with radical functions, and they give us more meaning as we move on and apply these techniques. You've also seen that we are able to factor a term out which was leading to 0. So if I substitute 2 here, both numerator and denominator became 0. So for 2, we had a form 0 over 0. So whenever we are working with 0 over 0, it is called undeterminate or undefined, and they could have some meaning if we rationalize and work it out. So I hope with this video you'll learn the importance of rationalization, and as you do calculus, you will see how this technique is actually used in so many examples, including finding rate of change, limits, asymptotes, and many other things. I hope you are enjoying this journey. Feel free to share your comments and views, and if you like and subscribe, that'll be great. Thank you, and all the best.